Hello students, you are welcome to this session. It is session 5 of Unit 5. The session is about titration of a standard solution of sodium hydroxide against a mixture of tetraoxophosphate 5 acid, that is phosphoric acid, and hydrochloric acid. We are going to use the continuous method to determine the concentrations of phosphoric acid and hydrochloric acid. Our objective for the session. By the end of this session, you should be able to determine the concentrations of H3PO4 and HCl in a mixture using the continuous method. Now, phosphoric acid H3PO4 is a polyprotic acid with 3 replaceable hydrogen ions, and so ionizes in 3 stages. Titration of phosphoric acid with standard base takes place in 3 stages. What are those stages? They are here. Look at it very well. The first stage is when one of the replaceable hydrogen ions is replaced, and so we have the sodium here, which has come to replace one of the 3 hydrogen ions here. And so we have NaH2PO4. It further undergoes ionization when we react or when we add another of the in the last proton here is replaced. So these are the stages that we would have to go through when we are to ionize phosphoric acid. We are going to apply these in the problem that we are going to solve. A is a solution containing unknown concentrations of phosphoric acid and hydrochloric acid. B is a solution of 0.1 molar sodium hydroxide. You have to put B in the burette, that is the acid, the base in the burette. Perform the following: pipette 10 cubic centimeters of A, that's the mixture, into the conical flask and titrate against B, the base, using metal orange indicator until the end point is attained, to the resultant solution. So once we see this, that means we are dealing with continuous titration or the continuous method. We add the second indicator and then record our values. We are to find the concentrations of the phosphoric acid, the hydrochloric acid, and we should show how to relate the volumes obtained in A to concentrations. We have been given the volumes of sodium hydroxide that was used at the metal orange endpoint to be 9.80, and that at the phenolphthalein endpoint to be 5.5. Okay, so let's approach the problem. Now these are the reactions occurring at the various endpoints. At the metal orange endpoint, we have the whole of the HCl reacting with the sodium hydroxide to produce the salt and water. However, with the phosphoric acid, we would only have the first ionization taking place. So it is just one of this replaceable hydrogen ions that is replaced over here. So we don't have a complete neutralization here. What is happening at the phenolphthalein endpoint? Remember, since it's a continuous something, we look at what is resulting from the metal orange endpoint. And here, since all the HCl is gone, we only have this sodium hydrogen phosphate remaining there. Okay, and here also we have the next ionization taking place, the second stage. So we have one of these 2 hydrogen atoms here being replaced by sodium. So we have this taking place. Okay, so let's let V1 represent the volume of acid used at the metal range endpoint and V2 at the phenolphthalein endpoint. Alright, so at the metal range endpoint, like we said, it is the first ionization that took place. So we said this one ionizes in 3 stages. In other words, you can divide this into 3. It was only one that was consumed. So, or if you divide this one into 3, one of it is consumed. So HCl plus 1/3 the phosphoric acid is equal to the volume of sodium hydroxide. In other words, the volume of sodium hydroxide that was recorded to have been used at the metal orange endpoint is the volume that converted the whole of the hydrochloric acid and 1/3 of the phosphoric acid. Okay, so let this one stand here because we can't do anything again. At the phenolphthalein endpoint, since the HCl is gone, we have this. So, like we said, if you divide into 3, it would undergo the ionization in 3 stages. Now, for the 3, one of them would be neutralized. So, 1/3 of the phosphoric acid is neutralized at the phenolphthalein endpoint. So, the volume of sodium hydroxide recorded to have been used is the volume that only converted 1/3 of the phosphoric acid. So if we want to know the volume of sodium hydroxide that would completely convert the phosphoric acid, we can do some extrapolations here. We can let or multiply through by 3, and this 1/3 will be gone. When it leaves, we have 3 times the volume at the phenolphthalein endpoint. So we will need 3 times 5.5, that gives us 16.50. This is the volume of sodium hydroxide that would be able to completely neutralize the phosphoric acid. So now that we have been able to establish this volume, then we can proceed and look at the moles of sodium hydroxide in this, and then we'll continue with the mole ratio. So we're given the concentration of sodium hydroxide to be 0.1 molar or mole per dm cubed. What that means is that 1000 cubic centimeters of sodium hydroxide contains 0.1 mole of the sodium hydroxide. So if 1000 is equal to 0.1, then this 16 will contain how many? It will contain 0.00165 moles. We proceed with the equation of reaction so that we can look at the mole ratio. And here the agreement is that for every 3 moles of sodium hydroxide, it will need 1 mole of the phosphoric acid for a complete reaction. So 3 is equal to 1. If 3 moles of sodium hydroxide is equal to 1 mole of the phosphoric acid, then that 0.00165 of the sodium hydroxide will be equal to what of the phosphoric acid? That will be 1 over 3 times 0.00165 moles, and that gives us 0.00055 moles. This is the moles of the phosphoric acid contained in that small volume that was pipetted or that was used. That's the 10 cubic centimeters. So we have to change into 1000 or 1 dm cube by saying that if 10 is equal to 0.00055, then 1000 is equal to what? 1000 is equal to 0.55 moles per cubic decimeters. So this is the concentration of the phosphoric acid. Alright, we need to look at the other component, which is the hydrochloric acid. Now, We wrote an equation. The equation was HCl plus 1/3 phosphoric acid being equal to the volume V1. But we have also established that 1/3 phosphoric acid is equal to V2. That's volume of sodium hydroxide used at the phenolphthalein endpoint. So we just have to do substitution. We place this 1/3 H3PO4 by this V2. So when we put it there, then we can take it to the other side of the equation, and we have this. So what is left is substitution. Let's put the values inside. We have V1 to be 9.8, V2 to be 5.5, and that gives us 4.3. So it is 4.3 cubic centimeters of the sodium hydroxide that completely reacted with the hydrochloric acid. Alright, so now that we know the volume of the sodium hydroxide that reacted, we can convert it into moles and continue with our mole ratio. So if 1000 cubic centimeters of the sodium hydroxide contains 0.1, that's the concentration, then that's 4.3 cubic centimeters that was used will contain 4.3 times 0.1 divided by 1000, and that is going to give us this answer, 0.00043 moles. This is the moles of the sodium hydroxide that reacted with the hydrochloric acid. So we can look at the equation of reaction. That is sodium hydroxide plus HCl giving us the salt and water. The mole ratio here is 1:1. What it means is that whatever moles of sodium hydroxide is the same moles of hydrochloric acid. So the moles of hydrochloric acid is also 0.00043 moles. This is the moles that is contained in that 10 cubic centimeters that was used. So to know the moles in 1000, then we can say that if 10 contains 0.00043, then 1000 will contain what? To contain 1000 times 0.00043 divided by 10, and that gives us 0.043 mole per tm cubed of the hydrochloric acid. This brings us to the end of the session. I hope you have really enjoyed this session.